In this video, we're going to be looking at making photoreal depth of field using the new Bokeh node in Nuke. The Bokeh node is a fairly new addition to Nuke, and I'm really excited to see that it's now included by default. Previously, it was a third-party node called PG Bokeh, and both the VFX studios I've worked at over the last 5 years have had licenses for this because it's really commonly used. Generally speaking, when it's used properly, this node gives a much more photorealistic look to any depth of field you're adding to your shots. It can be used in multiple ways. You can use it just on 2D sources, and it can also be used on CG renders with depth passes, and it can also utilize deep data, which is something I'll be doing a follow-up video on after this. So, first of all, before we get stuck into it, let's just touch briefly on the different types of defocusing you can do in Nuke. This is a render that I did a few months ago for a Christmas live stream. All I've got here is the background render of the factory with the lighting interaction on the floor. I've then got a couple of explosion elements which I've picked out and just put some glow on to make them look a bit nicer. And then on top of that is the render of the foreground objects. And I thought it would be a fun one to utilize today. So, defocusing in Nuke. There's a few different types of nodes you can use for defocusing. The most simple one is probably a blur node. This isn't even really defocusing, but it just does a similar effect. Then we have an actual defocus node. Then one that I also use quite often is the convolve node. I don't see this used all that often by compositors, so I think it's interesting to talk about this in the video. And then we have the Z defocus node as well. The Z defocus can be used on 3D renders, and it utilizes the depth channel. And the idea is that you can use the node to pinpoint where you want the focus to be. There's also settings for how shallow you want the depth of field to be, and then that point will be sharp in the frame, and it will create depth of field going closer and further away from the camera for you. So let's have a quick look at how they work. In terms of photorealism, I think these are pretty much in order of how good they are from left to right. The blur is the most basic and doesn't even really behave like a proper defocus, but sometimes you can just use it if you're just wanting to take a bit of sharpness out of a background plate or something. The defocus node is a bit more mathematically accurate in the way that the highlights and the shadows respond to defocusing. I really like using the convolve node because you can give it a kernel input, which I'll talk about a bit later. Using kernels, you can get some really interesting looking bokeh, and you can even shrink them down to get anamorphic looks and stuff like that. Then when we get onto the last two, they look a lot more photorealistic because of the way they use the depth channel. But they also make your scripts a lot heavier and require a lot more computing power to utilize. Some people that I've worked with before use Bokeh for pretty much everything, and while it creates a really nice result, it can be quite frustrating to pick up a really heavy script that's bogged down by having loads of these nodes. So it's a good idea to know how all of these work so that you can choose the best one for what you're trying to do. If you're just doing a small defocus, there's no reason to go for anything more complicated than the defocus or convolve nodes. It's actually a really important skill as a compositor to know how to optimize your scripts and not do anything that's overkill, which is going to bog you down at the end of a job. So let's do a little comparison of how they all work and the differences between them. First of all, we're going to plug in the blur, and let's try and get a similar amount of defocus on all of them. As you can see here, if I turn the blur up really high, there's not really a sense of defocusing, it's just smearing all the pixels outwards, and the way the highlights are interacting is completely unrealistic. If you shot this for real with a camera, the bokeh wouldn't be a square, and it wouldn't have this harsh cutoff either. So let's go for something like that. Then I'm going to do the same thing with the defocus node, and you'll notice immediately that the highlights defocusing more realistically, and the bokeh is a much more natural circular shape. So that's comparing those two. Already a much better result. Then we have the convolve node, which is my go-to for 2D defocusing a lot of the time. I have a folder full of kernels on my hard drive. Kernels are basically an image that represents the shape and the texture of a specific piece of bokeh. You can see here there's lots of shapes, so some of them are perfectly circular, some of them are a bit more angular, and these represent the blades of an aperture. So for example, if you have a 7-bladed aperture lens, then you'll see 7 sides to the bokeh. I'm going to pick one that's got lots of contrast so it's really clear what it's doing. This one's probably pretty good because it's very obvious that it's got a hole in the middle. Let's get another one as well. So then I'm going to shuffle one of the color channels into the alpha, and I might also grade it up a tiny bit just so it's a bit brighter. And now what I'm going to do is plug the filter input on the convolve node into the kernel. As you can see with the default settings, it looks a bit nuts. The convolve node doesn't actually have a slider in it that allows you to control the defocus amount. It's actually controlled by the size of the kernel itself. So if I add a transform node onto the kernel, and then I decrease the scale to something like 0.1, then it behaves a lot more naturally. Looks like I've got some negative values in my render, so I'm just going to add a clamp node just to get rid of all these dark artifacts. So like I said, using the transform node, you can increase or decrease the size of the kernel, which will affect the size of the bokeh. They're about the same now, but you can see how much more interesting the convolve is compared to a normal defocus. The amount of softening and the shape of the bokeh overall is pretty similar, but the defocus just gives you this standard circle and doesn't have any real texture to it, whereas the convolve is a much more interesting look. If I swap out the kernel for something else, you can see that it's completely interactive as well. So whatever you plug into the filter input, the bokeh will take on that look. Then we have the Z defocus. This is the first one that starts to utilize the 3D data of the depth channel. So if I plug this in and I set my output to focal plane setup, this is a render from Blender, so instead of using the depth data like a lot of other render engines, the information I'm after is actually in the mist channel. And then wherever I put the focal point, the depth of field in the shot will basically start from there. So if I set this on something that would probably be the subject of the shot, like Santa's face, I can turn up the depth of field a bit to make it a bit less shallow. The green line represents what's in focus, the blue is what's closest to the camera, and the red is what's going further away. And if I go back to render result now, you can see that the depth of field is actually working in a fairly photorealistic way, in the sense that it originates from where the focal plane is actually set in the shot, and then closer to the camera is out of focus, and further away is also out of focus. This is obviously pretty extreme at the moment. It looks a bit like a macro shot, so I'm going to turn the settings right down so that it's a bit more realistic. Something like that looks quite nice. The Z defocus node also has a filter input for kernels, so again I can plug this in here, and under filter type I can set it to image, and now we'll get the same effect, where if I turn up the settings on the depth of field, the bokeh will actually look like the kernel input that I've given it. So again, just to compare, this is the blur, this is the defocus, this is the convolve, and this is the Z defocus so far. Pretty wide variety in the looks we're getting there. And then finally we have the bokeh node, which in my opinion is the best looking of all of these. The bokeh node works in pretty much the same way as the Z defocus. So first of all I'm going to set my depth channel to mist. I'm then going to change my output type to focus distance visualization. And then if I look at my mist channel, I can sample the colors of where I want the focal point to be. So for example, if I color pick where Santa's face is, I can see that the value of this pixel is 0.036. So then what I can do is set the number of my focal plane to be that number. So here I'm going to type in 0.036. And then if I go back to looking at the RGBA channel, and I turn my focus region size down a fair bit, the red line that I'm seeing here is the focal plane of the camera. So now if I go back to defocused image and turn up these settings, you can see we get the same effect. Bokeh also has an input for a kernel, so I can plug this in down here. And then under the kernel options, I can set my kernel type to input. It doesn't like the way that I've transformed it, which is working for the other shots. So I'm just going to use a new transform over here, plug the input into this instead. In this case, it seems to be working. It doesn't actually need a transform, so I'm just going to delete this. It gets a bit confused on the edges sometimes, which is quite a common problem with defocusing using a depth channel in Nuke. And I'll talk about how to fix that in a second. But generally, this is looking really nice. So if we compare them again, this is the blur, this is the defocus, this is the convolve, this is Z defocus, and this is bokeh. You can see there just how much longer the bokeh node took to actually calculate properly. But if you have a really shallow depth of field in your shot, this is definitely the way to go because it's going to look the most realistic. So that's a quick demo of how they work. Now I'm actually going to use it properly on this shot. The first thing I'm going to do is defocus the foreground elements and the background elements separately. That way I'll be able to fix some of the edge problems that were occurring on the defocus here. I'm going to add a bokeh node onto the background, change my depth channel to mist again, then change my output to focal distance visualization and look at the mist channel. And I just want to sample where I want the focal plane to be. So here it looks like it's about 0.6. So I'm going to put 0.6 into the focal plane, look back at my RGBA channel, and as you can see, that's where the focal plane is in the shot now. And if I change it back to defocused image, turn up the size a little bit, we can start getting some depth of field in the shot. I think the focal plane might be a bit too far back, so what I can do is just change this number until it comes closer to camera. And I can also turn down the focus region size to make the depth of field shallower. I think that looks pretty good. It's not super strong, it's just adding a bit of softness to the background, and you can see on the concrete where the actual focal plane is. I'm going to grab this kernel from over here, just use this again because I think it looks nice. Plug in the kernel input, and then under the kernel settings, just make it utilize the input. This isn't going to do much to the look of the bokeh anyway because there's nothing super out of focus here. Then we have the explosion. On this, because it's just a 2D source of two pieces of stock footage, there's not really any sense in using a heavy defocus node. So what I'm going to do is just use a convolve on this. Again, I'm just going to use this kernel, and I'm going to add a transform node onto it so I can control the size. I don't want to go super soft, I just want to take a little bit of the sharpness out, just so it feels like it's not totally in the camera's focal plane. You can see that the little sparks are actually taking on the shape of the bokeh, which is always cool. And then finally we have the CG render that goes over the top in the foreground. Again, I'm going to add a bokeh node onto this and do the same thing as before. So I'm going to set my depth channel to mist. You don't have to do this if you're not using a Blender render. This is just specific to the setup that I'm using. If your renders are from something like Arnold, it will just be the depth channel. Then output type, focal distance visualization. Again, I'm going to sample where I want the focal point to be. Let's go for about here. So this is going to be 0.033. Look back at my RGBA channel and just turn the focal region size right down. Then change the output type back to defocused image, and then I can turn the scale up to make the depth of field more shallow. Again, let's just utilize the kernel up here, set the kernel type to input, and I reckon we can go a little bit stronger. Yeah, that's looking pretty good. Like I mentioned before, if you turn the strength up quite high, so let's go for something like 10, you'll be able to see that there's some strange things happening to the edges and we're getting some artifacts. The reason for that is that some of the pixels at the very edge of the depth channel have a value that doesn't completely correspond to where they are actually in 3D space. If I sample the value of the background, you can see the stuff back here has a value of 1, which is basically maxing out the depth channel. Then all of this stuff in the foreground of the car on the bumper is 0.36 or thereabouts. But then if I go to the very edge pixel of the car, it jumps up to 0.5. So the bokeh node basically interprets this pixel on the very edge of the car as halfway between where this pixel is here and the very background, whereas in reality it's right next to it. So the way to fix that is you can do an edge extension on your depth channel. To do this, I'm going to shuffle out my depth channel into RGB. I keep calling it depth, but it's actually called the mist channel in this case. Then I'm going to add a color edge. You can do this with any edge extension node, but color edge is the one that I use. RGB input goes into the shuffle, and then your mask is the alpha of the 3D render. And then I just want to invert the matte so that I'm spreading the pixels outwards. Then if I grow the texture, basically what this will do is eat into the edge of the alpha slightly and smear all of the color pixels outwards. So as I turn up this shrink matte slider, you can see that that white edge where the pixels are the wrong value starts to disappear, and it's smearing the correct color values for the edge of the car outwards, which should now mean that even the very edge pixels of the car will have the correct data for the depth channel. Then what I can do is add another shuffle node, plug this into the main stream, and plug the A input into the color edge. I'm going to set the input of the shuffle to be A, and I want to shuffle the RGBA data from the A pipe into my B stream, which is here. So we're getting the RGB input from A, and the output layer will be the mist channel. So now if I look at my mist channel, I might have to bring the exposure on the viewer up slightly, you can see that the mist channel actually now looks like that color edge. And if I turn it on and off, you can see the before and after. So now, if I look at the bokeh node, I can turn the scale up really high to exaggerate it. You can see there's no longer any crazy values on the edge of the car where the defocusing is happening. If I turn the shuffle off, that's the difference. Some of those edge pixels are getting defocused way too much. So if you do run into this issue, that's how you can fix it. It's quite simple. And that's all for this demonstration on how to use the bokeh node in Nuke.